last class we have learned about PCM modulation and DPCM modulation. So in PCM modulation we have seen that as the number of bits are increasing, or we are representing each and every quantized voltage level with a prescribed n-bit encoded value. So as this n-bit values are increasing, my bandwidth also increasing. Okay, this is a drawback of PCM modulation. And in DPCM, as we are taking only the difference between the two signals, so the bandwidth is reduced to a limit, but the system was very complex due to the use of filter. Okay, so now we will learn delta modulation. Okay, this is a third type of modulation we are using in our digital communication, that is delta modulation. So, in delta modulation, instead of taking the difference between the present sample value and the previous sample value, in this delta modulation, it will just compare both the present and the past, okay, and the previous sample values. And if the present sample value is greater than, okay, amplitude level is greater than the previous one, then this quantizer will, okay, then this quantizer will send one bit, binary 1, okay, and if the present sample value is less when compared to the previous sample value, then it will send 0, binary 0. So in DPCM and PCM modulation, we have been using some n number of bits to represent each and every quantized level. But in DM, only one bit is used, that is either binary 1, binary bit 1, or binary bit 0 to represent each and every quantized level. How it is using only one bit means it will just compare, means it will not take the difference between the present sample and the past sample value. It will just compare both the present and the previous sample values, and if the amplitude, if my present amplitude is greater than the past one, then it will send a binary bit 1. Okay, means 1 bit quantizer will send 1 bit, binary bit 1. Next, if my present sample value is less, amplitude level is less compared to the post one, that is previous one, then what happens is in this quantizer, which is also known as 1 bit quantizer, will send binary bit 0. Okay, this is a phenomena used in this delta modulation. Means even when the bit, even when the amplitude level is more or it is very less, it will send either 1 or send either binary bit 0. Okay, so as it is sending only 1 bit, it is known as 1 bit quantizer. Okay, so if we assume this is my analog modulation signal, okay, a signal, then my delta in delta modulation, okay, if my present sample value is greater than the previous one or past one, then this quantizer will send 1, and if again this present sample value is less than this previous sample value, then it will send binary bit 0. Okay, these are two cases and cases. So how my in delta modulation, in this delta modulation, this quantizer will start, okay, and then based on the quantizer output, a staircase, okay, a staircase approximation is generated here. So assume that as this amplitude is increasing, I will increase, and this is my step size, okay, delta step size, and sometimes it is represented by delta or this one delta. So in last class we have learned that step size is a difference between two sample values. Means what is the difference? Means difference equal, this is my sample value, first sample, and this is my second. So this is the difference between these two. Okay, step size is the difference between these two sample values. Next, levels. Okay, this is one level and this is two level, like that. Okay, and again my input. Okay, my sample value. Okay, this assume that this my amplitude further increasing, so my step will also increase to 1. Okay, like that. And again here amplitude is again increasing and again increasing. Okay, from here it is reducing, so I'll start reducing. Again it is reducing, I'll start reducing. See, it is further reducing and also further reduce. Okay, from here it is again increasing. Like this. So assume that this is my 0 delta. So when I compare due to the staircase, as it is increasing, then here 1, and again so in this line I will write this binary output. Okay, that is quantizer output. So I am making some dotted lines on this line in order to see how the performance is. So here I am taking this is from 0, it is starting from 0. So as my analog signal is increasing, my step size is increases to, okay, increased. So this is my 1, and again it is increasing 1, again it is increasing 1, again it is increasing 1. Okay, till here it has been increased. So here it is reducing. And 1. Okay, so again it is reducing. So it will see whether my present sample value is greater than or less than. So it is less than now. So it is 0, and again it is 0. Here it is also reducing 0. It is also reducing because see this my present sample value and this past sample values. When we compare, I have seen that this amplitude has been reduced. So it is 0, again 0, 0, again here see 0, 0, and again 0. Okay, and from here it has been increased 1, 1, 1, and again 1. Okay, so by using this delta modulation, I am getting this digital signal, okay, digital data here. So how it is generating this? First of all, by taking this analog signal and it is approximating a square staircase signal, okay, and then by using this staircase signal, I am able to see whether the quantizer output is 0 or 1. Okay, this is just a waveform, and next how this delta modulation is generating by using the staircase, how it is generating binary bit 1 or binary bit 0. Means it is just comparing the amplitudes, and if the amplitude is greater than the past one, it will send a binary bit 1. It will, if amplitude is less than the previous value, it is generating binary bit 0. Okay, this is a function. Okay, working principle of delta modulation. Now we will learn how a delta modulation means how a block diagram of generating this DM, okay, DM modulation. And here we have seen that the delta modulation, the step size is same, even though the signal is increasing a lot and lot, the step size is constant. Okay, means about delta modulation, you have to remember two steps. First of all, that is it is one bit quantizer. And the second point is the step size is constant. Okay. These are the two points we have here. there is some extra circuitry in that. We will learn that today. So about the delta modulation, remember these 2 points that in delta modulation the quantizer is a 1-bit quantizer and the step size is very constant. Okay, means it doesn't vary. So we have seen that this is my present sample value or a sample value. Next, this is my 1-bit quantizer. Okay. Next, a part of this, okay, the output of this quantizer is given through a delay circuit here. Okay. This sum. Okay, it is given with delay circuit. With a delay of sample delay. Okay. Next, it is fed to this one. This is my previous sample value. Okay. So in DPC modulation, we have got a filter here, but here instead of that one, we are using a delay circuit here. Means in order to compare both the present and the previous sample value, I am using this one. Okay. So here, this is my present sample value, and this is my past sample value or previous sample value. Both are fed to this summer, and an error signal is generated here. Okay. Based on this error, whether the amplitude is increased or decreased. Okay. If amplitude is increased, then binary bit 1 is generated. If the amplitude is reduced, then binary bit 0 is generated here. This is output of quantizer, 1-bit quantizer. Okay. And here, this circuit, which is a combination of a summer and this delay circuit, is known as accumulator. Okay. And here, what is this accumulator doing means it will generate some staircase signals. Okay, staircase approximation signal, and it will delay. Okay, it will delay this delay the generated signal. Okay, previous sample signal by a period of Ts. Okay, so that we can compare the previous sample value with the present sample value. This is the delta modulation generator. And after this, okay, about this one. So this is my DM output, okay, or else digital signal here. And in BBC modulation, we have seen that here we need to have an encoder, but in data modulation, there is no need of encoders or A to D converter. It is an advantage of using this delta modulation. So, first of all, see here in delta modulation, present sample value and the previous sample values are compared, and an error signal is generated. And this error signal is given to this 1-bit quantizer, and this 1-bit quantizer will generate binary bit 1 or 0. If the amplitude is increased, then binary bit 1. If the amplitude is decreased, then the binary bit 0 is generated. And this output is given to the summer. Okay, and also a previous sample value is also fed to this one. Okay, so here in this delta modulation, the output is depending on, okay, the output is depending on this summer output is depending on this quantizer, okay, this quantizer output and also this previous sample output, okay, and based on that staircase is generated and this value is delayed with a period of Ts. What is this Ts? Fs is my sampling frequency. Okay, we have seen that Fs must be greater than or equal to 2Fm. So this is my Fm, sampling frequency, and Ts is my 1 by Fs, which is sampling period. Okay, which is my sampling period. So the previous sample value is delayed with the amount of Ts, and next again it is counted. Again a one bit digital signal is generated, either 1 or 0. Okay, this is at the generation side. Okay, next in the same example, we have been using a circuit in the demodulation side and the receiver side. How next? First of all, a summer is used. Okay, here the digital signal is fed up. Okay, digital signal is given to summer, and this is my delay circuit Ts. And here a low pass filter is used. Okay, this is the process we have been using. Okay, this is my accumulator block. I think it is clear from the fact. This is my accumulator block. Summer and next delay. Okay, first of all, at the reception side, a digital signal is received and is fed to this summer. Okay, and this digital signal, okay, is compared, or else it is compared with this delay signal. Okay, delay output of this, it is delayed and it is seen in this one. Okay, so here a approximate staircase is generated like this and shown here. Here an approximate staircase is generated and the output of this one accumulator. So the output of this accumulator is fed to a low pass filter, and this low pass filter has function of does two functions. First one, it bandlimits the signal. Okay, it bandlimits the signal to the signal frequency, that is FM. Okay, it bandlimits the signal to this FM frequency, and next it will reconstruct the signal. Okay, reconstruct the signal. How it will reconstruct means it will just approximate the values. Okay, this the staircases. So like this signal is generated at the output of this low pass filter, analog signal. So at the transmission side also we are using an accumulator, and at the reception side also we are using an accumulator. Okay, here we are not in need of a decoder here, but in DPCM we have DPCM and PCM we have been using encoder at the transmitter side and the decoder at the receiver side. Okay, HOD and D2A converters. But here we are there is no need of HOD and D2A converters here. First of all, the digital signal is fed to the summer, and also the previous sample value, which is delayed, is also fed to this one. So based on this two inputs, a staircase, okay, a staircase is generated. How it is generated means if my digital signal out here input is 1, so I have to assume that my present amplitude level is greater than the previous sample value. So if this is my reference signal, so I will generate a step signal which is greater than the last one. Okay, if it is 0, if the digital signal is 0 here, so what I will do is this. Okay, till then from here, as the digital signal here is 0, I will reduce my amplitude to this one. Okay, like this. So a step signal or a staircase signal is generated here, and this staircase signal is given as input to this low pass filter here. So low pass filter, first of all, it bandlimits the signal to the converters and D-wave converters. And next one, next one, just the previous samples have been increased. And here, one more thing is that step size is constant. Okay. As the step size is constant, we don't need to transmit more and more power like that. Okay, power is also constant. So these are the advantages of delta modulation. Now we will learn the disadvantages of the delta modulation. Okay. So next topic is disadvantages of delta modulation. So let us assume a signal. Let us assume an analog signal which is continuous in nature. So if as we have learned that in delta modulation my step size is constant. Okay. Constant step size. You have to remember this one. That is, the step size is constant and it is using only one quantism. So, when amplitude is increasing rapidly, even though the amplitude of the signal, analog signal is increasing rapidly, my step size is constant. Okay, means it is just increasing one step only. Like this, okay, means it is not able to follow the amplitude or the slope of my analog signal perfectly. Okay, means even though the amplitude is increasing rapidly, my step case or staircase is increasing to one step size only. This is all delta, sir. Okay, from here it is reducing to one step again. So this is one. So what is happening here? Even though the amplitude of the analog signal is increasing continuously, it's very rapidly, fastly, my staircase, okay, my staircase is following just only one step only. Okay, means here it is not able to follow the slope of this analog signal or the message signal. So this type of distortion is known as slope over distortion. It is observed when step size is very small. Okay, means it is not able to follow the slope of the message signal. This is the first type of distortion. Okay, which is known as slope over distortion. It is observed when the signal amplitude is rapidly increasing or rapidly reducing. It is not at all following the slope of the message signal properly. Means it is just following its own rule that if the amplitude is increased, further increased, we have to increase the staircase, or if the amplitude is reduced, we have to reduce the amplitude. It is just following its rule, but it is not at all following the message signal. This type of distortion is known as slope over distortion. It is observed when the step size is very small. Okay, and next type of distortion is granular noise. Okay, granular noise. So what is that way? Take another signal like this. This is my continuous signal. So when the step size is very step size is very small, but in that case the step size is very large compared to the variations of the input signal. So because of this, what is happening here? Even though the signal is flat here, I am getting an output of 0 here. Okay? Even though the signal is flat here, I am getting an output of 0 here. So means I am not able to follow my variations in this analog signal properly. So this type of distortion is known as granular distortion or granular noise, which is observed because of this delta is very large. Okay? Means in both the cases, my staircase is not following this slope or the variations of the input signal. So, because of both the noises, that is slope over distortion and next granular noise, there exists lots and lots of errors. Okay, due to which the performance of the system is reduced. So, these are the disadvantages of using this delta modulation. Means here, even though there is some fast rapid changes in amplitude, my step size is fixed. Means it is not at all following that input message signal. This is a disadvantage. First one is granular noise, slope over distortion, and next one is as the step size is interferences is very large. So this is about delta modulation. Next modulation is adaptive delta modulation. That we will learn. Adaptive delta modulation. So, why these distortions have occurred means as this is not following this, following the message signal, as the step case is not following the message signal, we are going to get this both the distortions. But here, in adaptive delta modulation, the system is created in such a way that it should follow the message signal. Means if the amplitude is increased, that present sample value amplitude is more when compared to the previous one, then the step size is increased further. Okay, means here in adaptive delta modulation, the step size is not constant; it is variable. Okay, variable step size. Okay, so in this also, a comparator compares both the present value and the previous sample value. And if the present sample value is having an amplitude which is more than the previous one, so the step size is doubled. Okay, and if the present sample value amplitude levels are lesser when compared to the previous one, then the step size is reduced. Okay, it is halved like this. So by this we can say that in adaptive delta modulation, my signal or staircase signal is adaptive, means it is continuously following. Okay, it is continuously following the message signal amplitudes. This is a basic concept of this adaptive delta modulation, in which the step size is variable. Okay. So we will see what is the generation side, what are the blocks. So first of all is summer. This is my present sample value. This is my present sample value. This is a delays of TS. Okay. This is given to a 1-bit quantizer. Here also we are using 1-bit quantizer only. And this, okay, it's given in summer. And a extra circuit is here required, which is a logic for step size control, okay, or a step size controller, or a step size control. So, if you observe or compare both this DM with the ADM, we are having have this extra circuit which is step size controller or logic for step size control. So we know that this is my accumulator blocks. Okay, it is going to generate some staircase signal here. So first of all, here my present sample value and the previous sample values are fed to this sample. So and both of them are compared. When present sample value is greater than the previous one or past one, then step size is doubled up. Okay, and this quantity will send 1 only. Okay, 1. Finally repeat 1. And when my present sample value is lesser, means amplitude levels, I am comparing here amplitude levels. So when my present sample amplitude levels are lesser when compared to this past one, then my step size is halved. Okay, and a binary bit 0 is transmitted. By using this, my step size is able to follow or adapt the changes in the input signal variations. Okay, that is analog signals. And here the extra circuit which is used is a logic for step size control. Here this action of this increasing, whether to increase the step size or reduce the step size, is done by this logic for step size control. Okay, and here I am going to get my digital signal here. This is same phenomena which have been used in delta modulation, but the only concept which is different is step size control. Okay, this is at the transmitter side. The generation of this adapter delta modulation. At the receiver side, first of all, the digital signal is fed here and it is given to a summer. Okay, and this is my logic for step size control. And from here, okay, from here, it is given to a summer and it is a delay circuit here. After this, a low pass filter is used. This is my analog signal. Okay. So here we are having two circuits here. 1 and 2. This is my accumulator. Okay, who will generate some state-based signals. So in this first circuit, that is it's a summer, and next is a logic for step size control. In this circuit, it is able to generate or control the step size. Means based on the digital signal input here, that is binary bit 1 or 0, my step size is increased or decreased. If the digital signal here is binary bit 1, then my step size is increased or doubled. And if the binary bit here is 0, then the step size is reduced. The concept of reduction or increasing, okay, of this step size is controlled by the step size controller. And next, by controlling the step size, this input, okay, this output is given to a summer and a delay circuit, okay. This is my accumulator, and here this accumulator is able to generate a state-based signals. And next, this state-based signal is given to a low-pass filter, which will first vary with the signal, and next it will try to reconstruct the signal properly. Okay. So because of adaptation or following the input signal variations, here the in adapter delta modulation there is no slope over distortion and granular distortion. Means the errors or interferences are reduced in this adaptive delta modulation by using the variable step size concept. Okay. So we have seen that in PCM and DPCM the bandwidth was very high, and in DPCM it was slightly less when compared to PCM. Okay. And in DM modulation the bandwidth is reduced to further. Okay. The bandwidth of this DM and ADM modulations are same equal. Okay. Only thing we have to remember that in DM there was two distortions, slow over and granule noise. But in ADM these noises have been eliminated by using the concept of variable step size. Okay. So now we will see if this is my message signal. How it is able to do is, this is my reference signal 0. Okay. As step size is increasing, okay, this is my first step size delta, and as the amplitude is increasing further, my step size is doubled by using this logic. Okay, logic for step size control. This is 2 delta. Okay, and again here, as the amplitude is increased further, it is increased. It is again increased 3 delta. Orange. Okay, it's doubled. Next again, after this one, it is reduced. So here the step size is by 2, and again it is okay 4 delta, and again the step size is reduced to 2. That is 4 delta by 2. This is 2 delta here, and again it is further reduced. That is further reduced or divided by 2, that is delta here. Again it is further reducing to delta by 2. Again delta by 4 like this.